Hi guys, welcome to another RTPengine tutorial. This video is meant for developers, people who want to hack around the code a bit and especially want to learn about how to debug it if you run into any problems. In particular, we will be looking at memory leaks, how to debug them, how to find them. And I have here a virgin checkout of the code tree. We'll just compile it quickly. And if you run into some kind of problem where you think you may have a memory leak and you want to find it, the easiest thing to do, the first thing you may want to do, is run RTPengine through valgrind. This is very easy to do. You can, if you run RTPengine like this, normally I have some command line options here. You can use whatever you want. You can use a config file, doesn't matter. Normally you would just run it like this, and then you can simulate some signaling here. I have shown this in another video how to do this. And if you find that there's a memory leak when doing simple stuff like this, you can simply run it through valgrind like this. One important thing you should always do when you do this is you should set this environment variable for gslice, because we're using the glib gslice allocator quite a lot here, and valgrind doesn't quite know how to deal with this. So we can simply tell glib to just use the system-malloc for memory allocation, and then valgrind will be able to track this memory. One benefit of using valgrind is that you can use stock binaries. You don't need to compile it in any special way. You can use it from a Debian packaging, whatever, and it will work. The downside is that the performance impact, the performance penalty, is quite severe, and you can actually see this if you pay close attention. That is actually already quite a bit slower. For simple stuff it doesn't matter too much, but you definitely don't want to put this in the production environment. And then when you stop RTPengine with Ctrl-Z, you will get a summary if there were any memory leaks detected. Now what I will do, I will deliberately break the code, introduce a memory leak by just deleting these lines here. And then you can see what happens. Quickly recompile this, and then valgrind should be able to find this. So we'll do the same thing again. Run this. You can see it even takes a long time, relatively speaking, to start up. Do our quick offer answer again. Stop it, and there you go. It has found the memory leak. And then if you add these options, like here, valgrind suggests this immediately. You add it in here, giving you this full command line here. And then if you do the same thing again, it should tell you where the memory leak is. And it will also report other memory problems, buffer overflows, if you have stuff like that. And there you go. This tells you exactly where the memory leak is. Now, the other thing you can do, this is especially important or relevant if the performance penalty from valgrind is not acceptable for what you're doing. You can use the address sanitizer or libasan. Compiling it with like this requires a special compilation, so you cannot use package binaries. You have to compile it yourself. You have to set particular flags yourself. It can be a bit tricky depending on which distribution you're on. If it's an older one, you may be out of luck. You would need a relatively recent GCC, or you can also use clang alternatively. There is now for libasan there is a number of different things it can do, and the compilation flags will be different depending on what you want to do. So there isn't really anything included in the source code except one thing. We have this make target called asan-check here at the bottom. This is really meant to run the built-in tests. As you can see, this executes make check, but you can use this just to create a build on your own with libasan included, and you do this by setting this flag while doing the compilation. What this flag does is this is listed up the top here in the make file. This sets a number of compile flags and also runtime flags. And the other important thing to remember is that you absolutely must start with a clean build environment. So just start with a fresh clean tree, and then you can set this flag and just compile, and then just let this compile, and you will get a binary with libasan included. And then what happens is that you run this normally, as you normally would, without valgrind or anything like this, and those are actually mutually exclusive, so you cannot use both. And just see what happens when we do this. We take all our... So we want to... Okay, let's see. There's a few runtime flags here as well, and you can export those into your environment. You can see that the gslice one is included here as well. So this is necessary for both use cases, valgrind and libasan. And then we'll run our broken binary again. Now this is nice and fast. It doesn't take long like valgrind, but it is not as comprehensive as valgrind. It doesn't detect everything, and the reporting can be a bit confusing at times, but it's still good enough to catch some memory leaks. And there you go. Detected memory leaks. It tells you, and this is exactly the problem I just mentioned, that yeah, it tells you there is a memory leak. It's the 80 bytes that valgrind found too, but you cannot quite tell where this is coming from. Now, where it gets really interesting is when you cannot really reproduce a memory leak easily like this. And for example, it's one of the tests only that catches this. And this is what this asan-check makefile target here does. Just clean this up again and then run this. What the asan-check target does is it runs the compilation with libasan included, and then runs all the built-in unit tests and the system tests and everything. And then if there is a memory leak in there, one of the tests will fail. And what I will show you now is, if that happens, how to find out which test it is and how to run that test against, for example, RTPengine running out of valgrind. Because obviously the included makefile targets, they don't support running this under valgrind. And what happens is that if you run into this situation that one of the tests is broken because of a memory leak and the libasan output doesn't tell you where it is because it's just not precise enough, you want to run it under valgrind. So let's see how that works. Now the tests are running. The first test is running, and it should abort with an error at the end. And there we go. It seems like exit status 22 is the one coming from libasan. I'm not completely sure about that, but as you can see, you have the standard error output available to look at it. Let's see what that looks like. And yeah, this is exactly the problem. It doesn't quite tell you where the error is. So let's see how we can run this test manually under valgrind. Start with a clean build again, this time a normal build without libasan. And then let's have a look at the test directory. So this is /t in the code, in the tree. That's where all the tests are. Not everything here it actually runs when you run make check. Some are meant for manual testing. And the most important ones are the ones at the top here. They're called auto daemon tests. They actually run tests against a real RTP engine that's running in the background. The first one that is running is this one. That's the main auto daemon test script. That is quite large, does a lot of things. And we'll have a quick look at this, what it does. In the beginning of all of these auto daemon test scripts, there is one line or a couple of lines that have some command line arguments for RTPengine. Those are mandatory to be used for the test you want to run. They vary slightly between the different tests, so these must match what's given in the script between and what you run in RTPengine. The other thing that is important for this is this file here, tests-preload.so. That builds to a shared object, the preload library that is required for those tests. You can build it manually simply by saying this, if you have cleaned it up, the file, because if you run make check or something, this will build. This is very quick. And so what we're doing now is we're starting RTPengine from a second shell, as we normally do. And we are using exactly those command line arguments that are given here. In addition to that, we're using this preload library. And this works through an environment variable, ld preload, and you give the path to this file, like so, and then you just start RTPengine. What this preload library does is it sets up a fake network environment, so the tests are not running on a real network, and it doesn't matter what IP addresses you have and so on. The same thing you do with running the script, the test script. So you say ld preload. You need to give some kind of path, so one slash needs to be in there. And then one other thing that is needed, and I have to look this up every single time. There's another environment variable that needs to be set to 1, which is this one, that tells the test script not to spawn its own RTPengine in the background, but rather use the one that's already running. That's this variable here. So that's two environment variables that you need to set. And then you need Perl. You need to tell Perl where to find the Perl libraries. That is included in the tree. That's right here. One level up and Perl. And then you launch the test script you want to launch, like this. Make this a little bit larger so it fits in one line here. And then when I do this, you can see the test is running against the RTPengine that's running here. And there we go. Test is technically successful, but of course there's a memory leak. So we'll just do the same thing again we did before. We run this under valgrind. We set our gslice option again, and then run it under valgrind. And then we can say, I think leak check full, I think is one of the options you normally use when looking for memory leaks. And then we start this. It will be slow again, but the test will run through. It should complete successfully. And then when you shut down RTPengine, you should see where the memory leak is. Okay, one other thing is when you get this error. That's another thing I forget every time. what happens is that RTPengine runs out of file descriptors. Now, normally when you start RTPengine, it increases its own limit for file descriptors, but when running under valgrind, that doesn't work. So you need to do it yourself manually. For example, if you run on bash, something like this, so 10,000 FTs should be actually not C, it's N. Sorry about that. Slash dash N. That is how you increase the file descriptors. And then we do this whole thing again. And you could see already valgrind was complaining there, but we just want to make sure that the test actually runs through to the end. And there we go, test is successful. Now Control C, and there's your memory leaks. And that's it, that's the whole trick. Hopefully that will be useful to somebody who's maybe developing a little bit, maybe wants to contribute a little bit. All right, thanks for watching.